Rule 3. Is that like about showing your work? Urgent, important. Wait, they don't say that though. Oh, Brian, you've done that one for me. I remember you like explaining it too. Telling you how to do it? Oh, okay. It is an interesting trick, but I don't know, those kind of like number tricks have never been like my like the thing that I'm most interested in math, I guess. Like I like this finding the area of a polar curve sounds fun. Actually, you don't even need polar coordinates for this. Well, it'll be easier. They're gonna work involved to actually understand it, though. I think, right? um, using double integrals and polar coordinates. So they specifically need to do that way of finding this. Okay, so let's draw this thing out. And I'm just going to copy down the drawing here. Hey, Prev. Um, I'm about to do a. This person has to find the area of a shaded region with a double polar integral. So I'm just copying down the image that they provided. This line is x equals 3. We have to find this region, and the equation of the circle is x squared plus y squared equals 16. So the equation of the circle is pretty easy because x squared plus y squared is r squared. So in polar, that's just r squared equals 16. For the line x equals 3, I guess we do... Actually, let me make this a bit clearer. X squared plus y squared equals 16 turns into r squared equals 16, or r equals 4. For the line x equals 3, I guess we do r cosine theta equals 3, and then we divide by cosine theta. And that's not a problem because the thetas we're dealing with, cosine is never 0. Oh yeah, Bob. Okay, now that seems like kind of a fun problem, Brian. I mean, I'm sorry because I feel like I'm being a jerk, but like, I do prefer to do like problems that people like homework problems that people are asking about. But if I have time, I'll look at that one too. But like the whole like goal for my stream is like to help people out with their homework. So uh, and like the other stuff is like if I have time, I'll look at it. But what I really enjoy is homework, I guess. Okay, so if we do this as a, I guess we need to find the, how should we do this? So I think we want to integrate first in terms of r. The integrand is going to be r dr d theta. We want to go from this vertical line out to the circle. So we'll go from r equals 3 over cosine theta. And then for theta, we need to find where these two intersect at the top and the bottom. Actually, we could cut it in half too and multiply by 2, but I'll just do it this way. All right, I'm sorry about that, Brian. Hope work goes well. Okay, so we can figure out our thetas here by letting r equals 4 here. Basically, you know, if r equals 4 here, we can make that r also equal 4 and solving for theta. So 4 equals 3 over cosine theta. We would get cosine theta equals 3 over 4. That's not unit circle. That is the square of 3. No, it's not. No, yes, it is. It is a square of root 3 over 2. Is that significant? I don't think you really do much with that, though. Actually, oh, wait. It's not supposed to be unit circle. Maybe. If the radius is 4... Like, we could just have that, I guess. I just want to plug that into Wolfram Alpha or something, because it feels like something is off with that. Maybe it's not. Okay. I guess it's okay. Yeah. I guess it's just what we get. And the more I think about it, the more I think I do want to just do the upper half and multiply by 2, so I don't have to deal with like a negative angle there. So I'm going to stick a 2 in front and make my bottom bound 0, so I don't have to do the negative version of this angle. I feel like it's a bit safer that way, so you don't have to worry about the negative angle actually meaning something else completely. Okay. So let's integrate this. 0 arc cosine 3 over 4, 1/2 r squared, 3 over cosine theta to 4 d theta. 2 and the 1/2 can cancel. So we get 16 minus 9 over cosine squared theta d theta. Okay. That's going to be an annoying integral for secant squared. Actually, no, secant squared integrates the tangent. Oh, perfect. Okay, that's not that annoying. Okay. Let's come up here. Oops, sorry, I bumped my camera. Okay, so 16 integrates to 16 theta. 1 over cosine squared is 1 over, sorry, just secant squared. Secant squared integrates to tangent. So minus 9 tangent theta. And we have from 0 to arc cosine 3 over 4. So we get 16 arc cosine 3 over 4 minus 9 tangent of arc cosine 3 over 4. And then when you plug in 0, 16 times 0 is 0. Tangent of 0, that should just be 0. Yes, it's 0. We can simplify tangent of arc cosine. We can draw a triangle. If the cosine of this triangle is 3 over 4, then adjacent is 3. Hypotenuse is 4. That remaining side by the Pythagorean theorem is root 16 minus 9, which is 2 root 2. If I'm not mistaken. Yep, okay. So 16 arc cosine 3 over 4 minus now 9 tangent of this is opposite over adjacent. The 9, so it's 2 root 2 over 3. The 9 and 3 are going to cancel. So we get 6 root 2. There we go. That's our answer. Ah, okay. There's a bear behind me? Where? It even has 2 heads. Okay, I'm really confused. Like, I've seen multiple people refer to rule 3. And as far as I know, this is rule 3, and this person didn't do any of this, so... I feel like I'm just reading the wrong set of rules here. Are these rules? No? Maybe it's a stickied post. So I'd like to know the rules before I'm posting, but I feel like... these aren't numbered. And this is the second one. Dude, I don't get this, but anyway, it's not important. So I want to give them, like, you know, they didn't post their attempts, so I'm not going to do the problems for them. You know, I don't... now I'm getting paranoid. I don't want to make sure that the integrand should be RD theta. Okay, good. I want to... I want to post like what they should do without telling them what they should do, I guess. Okay. Sum of integers and squares. How do I progress on part B? Like a problem menu? Seemed interesting. Okay. Actually, they did get an answer, but you know, this might spark a, or it. If you want to see it, let's look through the question here. I wish I could. Ugh. Okay, so using the formula for sum from r equals 1 to n of r and the sum from r equals 1 to n of r squared show that the sum from r equals 1 to n of r plus 1 times r plus 4 is equal to n over 3 times n plus 4 times n plus 5. Ooh. So this first one is Gauss's method. And formula for the sum of squares, I wonder... It's actually... I mean, this will help you, Thunder. I'd actually try and like work this out for myself too and explain it. Actually, I could look at their work and see what formula they use, I guess. Oh, they expanded out. You think you got it? Oh, okay. We can still look through their work and see how they did it. This is their work for part A. They expanded out the multiplication, which seems like a good step. R squared, I guess. I assume it's this part. Older people on the test for A-levels. Oh, okay. That's really 5 over 2? And n plus 1? It's kind of... No, that's from this one. Okay, so they scrambled it around a little bit. The sum of squares, I guess, is the 1 over 6 and n plus 1 to n plus 1. The 4 n goes to the 4. I'm just manipulating it and factoring it again. Okay, so that's actually not too bad at all. For part B... Hey, Nyram. Thanks for following earlier. You're doing good. Hence, show that the sum from r equals n plus 1 up to 2n of r plus 1 times r plus 4 is equal to n over 3 n plus 1 times a n plus b, where a and b are integers to be found. Well... I guess you would take the sum from r equals 1 to 2n and apply the formula that you found here. And then you would subtract the formula from r equals 1 to n, period. Because I already said subtract. You would subtract that and show that it works out into this format here. So let's see if that's what the person said. Yeah, sure, Thunder. Oh, okay. So yeah, I don't have anything to add to this thread either. Still kind of a fun question though. Oh, it's one of these classic ones where You start with exponents, you turn it into logs, but the domain of logs doesn't include 0 or negative numbers, so you miss out on solutions. If the bases are the same, you can actually just like ignore the bases, but since they're not the same, I wonder if there's a trick that you can do. Is a question about the math terms? Yeah. What's up, Nayram? Okay, so I'll look at Thunders first. Or Nayram, if your thing is quick, I'll like just answer it quick too, but let's see what Thunder has to post. Part B? Okay. Oh, we got a triple sum. Algebra and analysis. I don't know what those mean and what fields fall under them. Okay, so yeah, I can try and answer that quickly verbally, although I've not studied higher level maths, so I can't give a very complete answer. Someone like Stuckey or Penn Center or Zach could probably give you a much better answer than I could, but my very basic understanding is how I think of them is like algebra is what you study if you want to invent your own type of math with different rules or different like formats. And analysis is studying like things within that type of math, like types of functions and things like that. But I only have a bachelor's, and I feel like that's something you study way more at higher level math. So pretty solid explanation. Okay, I'll take it. Thank you, Stuckey, for where does geometry fall under? I would assume it's its own thing. Geometry is cursed. Algebra? Oh, okay. Yeah, I'll definitely take Stuckey's word on that. For part B of this, I assume we're gonna have to apply Gauss's method a few times on this. Functions are analysis? Yes, as far as I know. Okay. So, or at least I've been calling it Gauss's method, but it doesn't really have an official name, so people call it slightly different things, or very different things. It's basically the formula for the sum of numbers from 1 to n. Okay. Being a little facetious, there are many more analytic kinds of geometry in this world. But the cursed shit is basically just algebra. Okay. I'll do it in blue. Every time you try to read, yeah, no, this one is, I'm not sure where this one is going to go exactly, but there's only one thing I can see to do, so I'm just going to hope for the best and try that thing. J equals 1 to n. I equals 1 to j. Actually, oh, I didn't realize that it's like going to the left. Oh god, okay. And the sum from r equals 1 to I of r. Okay, so you'd also said something about topology. As far as I know, topology is like geometry on steroids. That's about all that I know about it. So I'm really not sure where this is gonna go, but my only idea here is to work from the inside out. And because I noticed on here on the inside, we can just apply Gauss's method and hopefully something good happens there. So let's do that to the inside and keep the outside the same. That is such messy writing. Oh my god. J, and then this entire thing inside here is equal to, wait, is it 1/2 or is it 2? I think it's 1/2. I times I plus 1. Now I'm questioning that. What is geometry when you can't measure distances or angles? Is it nothing? Gauss, maybe I'll Google Gauss summation here. Sorry about this, because once I actually start to do the problem, then I start to question the formulas that I'm using. It's a problem. And I know that the browser is a little bit messy. It is 1/2. That's all I wanted to know. Okay. Okay, and so then, how do we work out this sum now? I guess we multiply this out. Actually, I think it's going to do the same thing as the problem that we looked at. Oh, thank you, Nairam. And I'm sorry, I feel like I'm saying Nairam and Nairam, alternately, but I hope that I assume it's Nairam. Please correct me if I'm wrong, though. So yeah, Thunder, you're saying yep. Okay, so let's multiply it out and use a similar thing as what that other problem that we looked at together did. It's 1 to j of 1/2 I squared plus 1/2 I. So now this could be another Gauss sum or Gauss method, whatever your persuasion is. And that, I already forgot what the formula they used is. How the R turns into an I? Okay, that's a good question. So let me back up. It's because of the way that the formula works. So if you have if we have a completely different scenario with the sum from I equals 1 to n of I, just like the general version of Gauss's method, that formula is always whatever is last, your upper index, 1/2 n plus 1. Like, the I in this case is completely irrelevant because the formula only cares about your last bound. As long as you start at 1, that letter can be whatever it wants because we only care about the upper bound there. Even with always use n. Oh, okay, so yeah, and here they have too many sums to only use n, I guess. Yeah, it's just how the formula works. Maybe there's some other, well, actually no, it doesn't make sense to use I in the end result. Because I is what you're like changing, I guess. Really, whenever you have sum like this, I guess I is really just your placeholder for the actual numbers. It doesn't mean that much on its own. Because I's are just gonna be 1, 2, 3, 4, 5, whatever, all the way up to n. But yeah, okay, I'm glad that sounds like it makes sense. The formula for I squared, I already forgot what the person had on their paper for what that formula was. Let me see if I can find it quickly. 1/6 n 2n plus 1. Okay, thank you, Thunder. Yeah, if that was your only question about it and you understood that, and I'm sorry for explaining stuff that you already understand, but I'll still follow it through in case there's someone else who's lurking who wants to see the answer. Okay. So actually, I'll show this in 2 steps. I'm going to split this up because when you have a summation, you can like distribute it in into each of these terms. That's probably not the best term to use, but I'm using it. I equals 1 to j. The 1/2 is just a constant coefficient as well. You can put it on the outside of the sum. Oops, it helps fight. I still need the I squared though. Then I'm going to do the same thing over here with its own sum. Okay, so this part here and this part down here are completely equivalent. It's your only real question? Okay, sounds good. I'm also curious to see how it works myself, so I'm still gonna like go all the way through it, but I'm glad that you're comfortable with it. So here we can, the I squared, we can apply the formula that Thunder gave me. 1/2 stays on the outside. And then the formula is 1/6 n plus 1 2n plus 1. Oh, I'm sorry, not n's, j's, because j was the upper bound there. Two j plus 1. Plus 1/2. Now on there, the same formula, 1/2 j plus 1. Okay. So now we do the same thing, multiply this all out. I guess we're going to get a cube here. We need the formula for that, but I'm sure there is one. So, oh god. That's some annoying algebra right there. Get 1/12 j cubed, oh, 2j cubed, ugh. So that's going to be 2j squared. We're going to get 3j squared plus j. I'm doing that right? I think so. Oh, thank you for giving me the one for cubed as well. Gonna need that. Okay, so I'm pretty sure I did that math right there. Then over here, got 1/4 j squared plus j. Now we need to distribute in the coefficients and combine like terms. So 1/6 j cubed plus, we do have 2j squareds here. We have a 1/4 j squared plus 1/4 j squared is 1/2 j squared. We have a 1/12 j and a 1/4 j, which is 4/3j, which is 1/3 j. Yeah, 1/3 j. Fraction math. And now, hopefully, when we apply the formulas, it'll turn out to be something that's not disgusting. So the j cubed, we still have the 1/6 out front, but then we can use the formula for cubes, which is 1/4 n squared. Oops, I literally said a quarter, but I didn't write it. 1/4 n squared n plus 1 squared. Interesting, I was just the initial Gauss's formula, but squared. I wonder why. Now we use the formula for squared again, which was 1/6 n plus 1, 2n plus 1. Then Gauss's sum right there, 1/3, 1/2, n plus 1. Oh god, okay, that's an annoying amount of algebra. Actually, you can do some grouping stuff. This won't be that bad. Okay, so I was about to just say, okay, you know, F this, who wants to do this, but all these terms have an n, and they all have an n plus 1. So we can factor those out off the bat, and we'll have some much simpler algebra after that. So I'm going to take out an n plus 1. Then we'll have some ugly stuff in the brackets, which we can't avoid. 1 over 24. We still have n plus 1. So I'm going to say n times n plus 1 is n squared plus 1 over 24n. That is just 2n plus 1 times a half, so plus n plus a half. This is a third times a half, which is a 6. That's not too bad. n plus 1. That is going to be annoying to factor still. We can probably factor something out, though, I guess. 1 over 24 n squared plus 25 over 24n. A half plus a 6. What is that? 4 over 6, which is 2/3. If you take out the 1 over 24, that seems like a good idea. n plus 1, what do you end up with? N squared, it should be something simple to factor. 25n. That times 24 is 16? That doesn't factor. Not the way it's supposed to. I made a slight mistake. It should be n plus 3 times n plus 4. Take out a 12th? Oh wait, I made a mistake? Oh, you don't have points? Where did I forget the 1/12? There? Oh, I forgot the 6. You're absolutely right. Oh no. Okay. Thank you for that, Thunder. So these two terms are wrong. So I took out the n and the n plus 1, and I remembered the 1/2, but I forgot the 1/6. Okay. Not all the work is wrong, though. Only a part of it, thankfully. Okay. So that's a 12 times 2 is 1/6 n plus 1/12. Okay, that should give us something that factors better. 1/24 over 1/6 is 5 over 24. A 12 plus a 6 is 3 over 12, which is 1 over 4. Now when we take out the 24, we get plus 5n plus 6? Question mark, yeah. And that becomes n plus 2 times n plus 3, so we've proven the initial thing. Okay. Oh, I accidentally covered up the bottom line on my work. Sorry about that. Okay, that is kind of a fun one. It's a lot of algebra, but thankfully you can use that little shortcut. Hey, Datas. The question was to prove this identity here, and you have this really mean triple sum. But it's kind of a fun problem if you know the formulas involved, so. Yeah, glad I was able to help you understand the issue with why the R turns into I. Are series similar for loops and programming languages? Yes. If you know of a for loop, well, yeah, you just said for loop. I skipped over that. They're exactly the same. I think a for loop in programming is a bit more flexible than mathematicians tend to use series. can do some funkier things. I mean, I guess you can also make them flexible in math too. But I think like you could do a for loop with only even numbers, or you know, you can do some fancy things with like manipulating your index in programming. It's actually I don't think it'd be that hard to program that by just making this like triple sum. Or you can do them one after another probably too. Because it'd be, well, actually no, it'd be hard, you have to be given a certain thing. Hey, mangoes. Yeah, I remember there's this one, I used to be a research assistant for a professor, and I'd like take over someone else's code, and like modify it, and they were doing all sorts of fancy stuff with like, oh, in this case, add one to the index and skip over it. In this case, subtract one from the index and go back to this other thing, and it was really hard to understand what was happening. You having a good time with this? Oh, do you post it? Okay, let's take a look. Which one is it going to be? 8A, okay. Sympology is a book by Ghost Hardy. Ghost Hardy is a cool name. What the hell? Oh, G.H. Hardy. Oh, okay, I assume that's a pen name. Or just or like a nickname. What was it about? Okay, so we have AA. The line with the equation 2x plus y minus 5 equals 0 is tangent to the circle with the equation x minus 3 squared plus y minus p squared equals 5. Find the two possible values of p. Ooh. Okay, let's draw this out. I know that's where this is gonna go. The main of New Infinity. Oh, I haven't heard of that one. Oh, let me get rid of the webcam. Oh god, I forgot the blue. It erases like crap. Ugh. Okay. It's something to do with the discriminant, and you keep messing up somewhere. Expensive mathematics for math's sake, despite applications for it. Oh, okay. The only movie you ever went to alone? Ooh. I don't think I have been, but I would. Like, I've been to a movie alone. Alright, so we have 2x plus y minus 5 equals 0. I hate that format for a line. 2x plus y minus 5 equals 0. And we have x minus 3 squared plus y minus p squared equals 5. I'm going to immediately put that in y equals mx plus b form because I hate looking at that in its current format. Okay. So there's two possible values of p here. Good Will Hunting. Oh, yeah, I guess that's a math movie. It is a really good movie. Interesting. Okay, so we have an interesting dynamic here where 1, 2, 3. We have a circle of radius root 5, which is a little bit more than 2. The x center is fixed at 3. but we can move it up and down arbitrarily. So let's graph the line first, maybe. So we start at 0, 5. We go down 2 over 1. Just a rough drawing, this isn't exact. So we can have one circle. If we're fixed with x equals 3, we can have one circle above it. It's a horrible circle. And one circle below it, like way down here. Okay. And it's a number. Oh, interesting. Okay. And so that's what's happening, I guess, visually. How do we do this with math, though? I think that to minimize the distance from a point to a line 2 times. And then what? This is... Actually, no, the distance is root 5. We might need to use that formula, though. Okay, you don't fully get why that's what they do. Wait, they use discriminate sub and y and use b squared minus 4ac equals 0. So they take... Are you saying they take, like, this y here and plug it in over here? That's actually, I think, a good idea. And we know that x is 3, so we could plug that in too and solve for p. Okay, so... Okay. That's actually really helpful. Thank you for saying that, Thunder. So I think what they're doing is whenever you want to find when two functions intersect, the first thing you should try is, I mean, it wasn't the first thing that I tried to try, but you basically set them equal to each other, or plug one into the other, and that'll be where they intersect. So they're doing the same thing here, even though we have a p, that's what we want to solve for. So the equation for the line is nice and clean, the one for the circle isn't, so let's plug the line into the circle and work with that. If we know y is equal to 5 minus 2x, plug that in there. X minus 3 squared plus 5 minus 2x minus p squared equals 5. And further, we know in this situation that x equals 3, so we can plug that in. Three minus 3 squared plus 5 minus 6 minus p squared equals 5. So Thunder, they plug that in just because like a simpler case that you've probably seen before is if you want to find where two lines intersect, like if you have a line like that and a line like that, you would take the equations for each of those lines and set them equal to each other and solve that for x. Oh, sorry, it's slightly cut off, but you can see the important part. Another thing that you could do when you have that situation with two lines is take one and plug it into the other. There's just not a huge point in it with lines because those are simpler. But okay, good. It's the same exact like logic, just with circles now, where things are a bit more complicated. And so it sounds like that was like your main question about it, but I'll still like fall through the math like I did last time. So 3 minus 3 is 0. That's -1 minus p squared equals 5. We can square root each side rather than multiplying it out. Actually, we should not square root each side. Well, we could. I'm going to multiply it out, though. We'll get p squared plus 2p plus 1 equals 5. I just didn't want to square root each side because then you have to do plus or minus root 5, and I didn't want to deal with putting into two different cases and potentially... Central, I hate you. You're more so confused with the discriminant being b squared minus 4ac equals 0 and not greater than 0. No, you don't? Oh, okay, you're right. I only slightly dislike you. You're more so confused about... So I assume the discriminant... Well, okay, let me get the 5 words to the other side. So I don't see why you would... Or why you wouldn't... use the quadratic formula there. Like, why are they messing with b squared minus 4ac equals 0? I don't know that either. Like, does my work here match what your book did so far? Right. 999 times 999. Technically, I do have a stipulation that I only do 2 digits, but I feel like there's a trick there. You would do 999 times 1,000, which is 999 with 3 zeros, and then you subtract 999. So is that 998,111? It seems a bit off. How do you get x equal 3? Oh, should I not have assumed that? Oh, maybe I shouldn't have done that. That's a good point. We know the circles just said x equal 3. But we're trying to find the x's where they intersect. I'm sorry. So yeah, I'm sorry. X equals 3 is bad. Bad. I'm doing the wrong thing. Thank you for saying that. 1,000 minus 1 squared is also a method. I think with quadratic that I got, it wasn't going to be a good thing. 1,000 minus 1 squared. Oh, so you do 1,000 times 1,000 is a million. A million minus 2,000 is 998,000. And then you subtract, you add 1. So 998,001. Okay, so yeah, I think Stuku is going off my flawed work, so that's probably why it didn't make sense. Yeah, I think we need to keep the x's in here. We can't say that x equals 3 because we're looking at the intersection point between the circle and the line, which isn't necessarily at x equals 3. In fact, we have 2 different x points. By fixing x equals 3, I did something completely different that I have no idea what it means, but we have to keep it like this, and then I think I know what we're doing with the discriminant thing. 998,001. Okay, yes. That's a neat trick, Brian. Okay, so let's multiply out the x minus 3 squared minus 6x plus 9. This, let's multiply it out in 2 steps. 5 minus 2x squared. I'm just going to treat that 5 minus 2x as one unit as I square this out. There's a more direct way, but I'm just going to do it like this because it makes me happy. Minus 2 times these multiplied each other, minus 2p 5 minus 2x plus p squared equals 5. Now we need to multiply it. We need to do some more multiplying out here. That's going to become 4x squared minus 20x plus 25, if I'm not too bad at math. Yes. Okay. Plus 4px minus 10p plus p squared equals 5. Okay. Let's group up our terms based on the x's. So we have x squared, 5x squared, minus 6x minus 20x plus 4px. Minus 26 plus 4p times x, like that. I'm going to factor the x out. Sorry, I should have said that more explicitly. Then all the constants, 9, 25, 10p. 9 plus 25 is 34, minus 10p. Oh, we can bring the 5 to the other side too. 34 minus 5 is 29. Equals 0. Okay. So this is a quadratic, and you're not playing Super Mario Bros. 3? What's wrong with that, Jeff? It seems like a great time. End Center, thank you so much. How's the stream? Appreciate the raid. Wasn't bad, wasn't math? Oh, I mean, out of the group, Jeff, I stream not math the most, so you should be mad at me if anyone. Hello, Dawnfather. Hey, Pen. Hey, Beef. So yeah, right now we're working on a problem from Thunderfix. It's in the corner of the screen there. Hey, Enigma. Always here when you're on Twitch. Oh, not Jeff. I do so many games. I guess it's just the timing. I forgot the p squared at the end. Oh, thank you. Good catch. Twitch only exists when you're on Twitch. There you go. Okay. So the realization, I guess we need to make some realization for why the determinant or discriminant of this quadratic must equal 0. Are the circles... Oh, that surprised me. A My Little Pony? Oh, God. Okay, well, let me... Oh, hey, Hardlocked. He plays a lot of My Little Pony. Yeah, exactly. Okay. Well, let me work through this problem, and then I'll draw you the best My Little Pony you've ever seen. Oh, god dang it. Thunder. You're absolutely right again. I'm getting distracted, but well, once I work through this problem, I'll get on that drawing pen center. So, what is this? I think what's happening here... No. It's not what's happening here. Something about this, it has to be a repeated root. Because that's what the discriminant being equal to 0 means. You can have a cat and a pony? Yeah. Why would that have to be the case? Whoa! Anonymous, whoever you are, thank you so much for the 5 gift subs. Holy crap. Who got them? Talos Teaches, Perp, Matt GY, Stooky, and Fish? Holy crap. Whoever did that, thank you so much. I really appreciate that. I'm glad I'm not doing a subathon. It would have been plus, what, 15 hours? Oh my gosh. Thank you so much, whoever. Donathon. Oh god. I better get the right answer now, jeez. Just like Batman, mysteriously in the night, they give subs. And I appreciate them. Taking puppy for a walk? Alright. Enjoyed the walk. Is adult humor allowed here? Yeah, Jeff. Like, cursing and all that stuff. I mean, I wouldn't go too far into... It's still Twitch, so don't be too offensive, but... I don't know. Dick, butt, vagina, boobs. If that makes you feel better. Feel free to take a photo of the pony and DM you. Oh yes, I'm sorry that you'll miss it. Yeah, just for posterity, I'll put the pony in Discord. You see sideways boobies with. Yeah, whenever I draw a circle with the center marked, I always see boobs too. But they're pretty far apart, I guess. Hopefully Twitch won't ban me. You know, they did just reverse their policy on artistic nudity, unfortunately, after like 5 hours or however long that policy lasted. Yeah. Okay, well, why would we... How do we know the discriminant is 0? There must be some... Okay, so... P is the y coordinate of the centers of the circles. I feel like this is one where it might... I really try visualizing this. I wonder if the x's are going to be the same for where they intersect somehow? There's not necessarily at 3? Artistic pussy on my board. Yeah? So, okay. Thunder, I think for this one, I'll be able to give a better explanation if we just trust them with the discriminant thing equaling 0, and then we'll do a graph of this after, because I'm not quite sure either. Hey, Skirtle. Hope you're doing good. So discriminant is b squared minus 4ac, 4 times 5 times, oh god, that. Because there's some kind of conclusion about where the circles must be that I can't quite draw. The thing says always, so you clicked it. Oh, it always like pops up. Okay, so let's multiply this out, and I guess let's solve for p. 26 squared. What was that memorized? $676. Okay. Ugh, this one's so annoying to multiply out. 676. What's 26 times 4? 26 times 5 is 180? No, 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 no. Dude, never mind. Is it 180? SPQ, if there's a simple solution, I'd love to hear it. 104? Okay. Thank you, Jeff. You're right. Times 2, so 208. Um, 29 times 20. 29 times 2 is 58. Add a 0. 200p minus 20p squared equals 0. Okay. We observe that a normal to the tangent line is y equals x over 2 plus c. Oh yeah, because you take the slope, flip it, and negate it. Okay. At x equals 1 and x equals 5. Oh, thanks, Enigma 2. Okay, I'm having a hard time figuring that out right now. SPQ, this is the way these Thunder's books said to do it, so I'm gonna follow this through and then I'll think about that more later, because it's hard for me to follow too many different trains of thoughts. P squared and p squared is minus 4p squared. Minus 8p. 676, 580. 96? $96, okay. We can divide out the 4, the negative 4, I'll say. 24? Okay. Okay, multiply to negative 24 adds to 2. 6 and 4. We want plus 6 and minus 4. P plus 6, P minus 4 equals 0. So P equals positive 4 and negative 6 for some reason. Okay, so that is the right answer. Let's see if I can figure out how you would know to do that discriminant step, though. Because that still makes no sense to me. I want to see what these circles look like, because I feel like I'm missing some kind of intuition about what the graphs must be. Oh, not 3D. It's one too many Ds. Some real tangents and circles with a discriminant must be 0. Really? Do you remember the name of it? Excuse me, Desmos? Did I type something in wrong? Why is that not a circle? Oh, cubed. Oops, cubed. I made a hat. Wait, why didn't those gift subs didn't show up in my actual activity feed? It's kind of concerning. Okay, well now they do. I don't know why they didn't before. Well, circle tangent discriminants. Let's just see what comes up with that. Because it does make sense that there's only one solution for a tangent line. Yeah, sorry, SPQ. Okay, so I think it's because if we only have the case with one circle here in an alternate version of this problem, we'd have to be given the 4 here in the circle rather than the P that we actually had. And if you do that same procedure with plugging the line into the circle, you would still end up with a quadratic, and that quadratic must only have one solution for the line to only intersect the circle once. Which is basically what you said. It's very... It's very weird because it's particular to this technique. Because I think there's some lower lobes. Yeah, I don't think Thunder is doing calculus yet. So we have to not. I was about to say, it's like you could do there's a calculus way to do problems like this, where you don't have to worry about this sort of stuff. But because we're using this particular technique where we always end up with a quadratic, it can only have one solution because they only intersect once. If the line was shifted over to the right and there were 2 intersection points, then the discriminant would be greater than 0. But we only expect one solution to this particular intersection of 2 graphs, I think is the rationale. And there being 2 circles just means we have 2 separate problems, I guess, but it's the same idea. So yeah, no, I'm still having my head around it for myself. Yeah, there's only 2 possible values for P, so I guess that's why we get 2 things, but it's still discriminant still equal to 0. Because on an individual level with each of those circles, I think they only intersect once. So that's probably, I bet if I slept on it, I might be able to explain it better, but right now it's the best thing that I can think of.